Alright, welcome back to PA Academy. So this is the second example we are going to be looking at under divergence of vector, and this is another example under solenoid vector. Exactly. So at the end of this video, you also understand what solenoid vectors is all about. Alright, so here is the question. It says if A is equals to 2x square y, the coordinate is I, minus 2 into bracket xy square plus y cube z, the coordinate is z, plus 3y square z square, and then the coordinate is k. So we are asked to determine div A, that is div A. So another thing you need to note is that sometimes the question will not tell you if it is divergence or gradient or curl. So you also need to understand the symbol. Exactly. For example, this is for divergence. Exactly. So this question was, should I say, straightforward enough to also add this to it, that is divergence. So that's one thing you need to take note of, how to identify divergence and how to identify curl. So just for me to mention, so if you just have something like this with A, exactly, so this is for gradient. So but once you are having a dot sign in between it, then you should know that this is for divergence. Exactly. So that's just by the way. So when we get to curl, we are still going to talk about it. All right, so now let's continue. So this is the question, and we are asked to look for the divergence. That's div A or div A, whichever way you want to call it. All right. So again, so let's start with writing out the formula. So we know that div A is as partial differential I plus partial differential, that will be j, for y plus partial differential over partial differential of z. Okay, so that would be, and then the dot product of A, which is the function, which is this. Exactly. So what we are going to do is to write this. So we are going to be having 2x squared yi minus. So to make the work much more easier, what I'm going to do is I'm going to just open up these brackets with these two. So I'm going to be having minus 2xy squared minus 2. So that will be minus 2y cubed z, then the j, plus 3y squared z squared k. Are we good? So now, just like we did in the other example, so we are going to use what we are having here to multiply this, and then this, the one for j will come and multiply that of j. So j is from here to here, and then the one for z will come and multiply that of z, which is from here to here. So from here to here. So now let's do that. So that means our du of A will be the partial differential. So I just need to write it out so that I don't just want to skip this step. 2x squared y. So like I said, once you are multiplying it, the same coordinates, once they are multiplying themselves, the I will no longer be there, the j will no longer be there. So if this is multiplying this, remember they are on the same coordinates, the I will no longer be there. Then, so if this is also multiplying this, plus e over the y minus 2xy squared minus 2y cubed z, then plus, so let me just take this off, then plus partial differential over partial differential of z, that will be 3y squared z squared. Are we good? So let's go ahead. So now if you look for the partial differential of this with respect to partial differential of x, that's going to give us 4xy. So now let's do for this side. If you have to do this, this is going to give us minus So this is y square. We should differentiate that as 2y. So that will be, then we are also having 2 at this point here. So that will be minus 4xy. Then if you also differentiate this is 3 cube. If you should differentiate 3 cube, that will give us 3y square. So if the 3 should come in front with this 2, it's going to give us minus 6. So you're going to be having minus 6y square z. Exactly. So I want to believe, again, you won't have problem with this if you have been following like the previous set of videos. We've touched this extensively. Okay, so now let's continue. We are done with y, so let's go and look for the partial differentiation of this. So this is z, and then for z square, if you differentiate it, that's going to be 2z. So if you use the 2 to multiply the 3 we're having at the front, that's going to give us 6. So that will be plus 6y square z. Remember, nothing will happen to y because we are taking y square as a constant. Exactly. So now let's simplify this. Now, what do you notice at this point? You can just pause the video and look at what we are having at this point and look at it closely. Look at it closely for like 5 seconds and see what did you notice. Alright, so let's see if your observation was correct. So you'll notice that this is 4xy minus 4xy. This will cancel out. Exactly, that will give us 0. Minus 6yz plus 6yz, this will also cancel out. So what that means our answer, so we can conclude that our answer is, so that means our div of A is 0. Now, when this happens, when you solve a question under divergence of a vector function and you are getting your answer to be 0, so you can just conclude that such vector is what we call a solenoid vector. A solenoid vector. So once you have a vector, after calculating the divergence of that vector and you are getting your answer to be 0, so you can just conclude that that vector is a solenoid vector. So I hope you got that. So in the next example, we are going to be looking at another typical example under solenoid vector. It's different from this, but it has to do with understanding the fact that once you have a solenoid vector, is always equals to 0. Exactly. So you're also going to be using the idea to solve some other question in different dimensions. So we are going to be looking at that in another video. So I'm going to be stopping here in this particular video. I'm going to see you in the next one. Again, if you find value, please give it a thumbs up. And if you are still here to subscribe to PE Academy, please click on that subscribe button to subscribe. And I'll see you all in the next video on solenoid vectors.